Hi all, today we are going to see about the lecture series on Unit 2, Unit 4, 2 in Design and Analysis of Algorithm subject. So the Unit 2 is about brute force method and divide and conquer. What do you mean by brute force method is exploring all the possibilities to solve the problem, and divide and conquer means we are going to divide the problems into subproblems to solve the subproblems and then combine or merge the solution to reach out the. Hi, the second topic in brute force technique is bubble sort. Previously we saw about the selection sort. In selection sort, the elements in the list will be compared with all the other elements. One element in the list is compared with all the other elements in the list. So in bubble sort there is a difference. So we are going to compare the adjacent elements of list and swap if they are out of order. So this is the basic procedure we are going to follow in the bubble sort. Wherever in selection sort we are going to compare the one element with all the other elements in one pass, but in bubble sort we are going to compare only the adjacent elements of list and swap if they are out of order. So doing it repeatedly will bubble up the large elements to the last position of the list. So this is the ultimate procedure of the bubble sort. So we are going to consider an example with array of items where the elements are 89, 45, 68, 90. The same example which we considered before. Okay, here our n is equal to 7, n minus 2 is 5, and n minus 2 minus I is equal to, we have to going to pass out with the passes. So pass j, we are going to consider how many number of pass in one ith pass. So here our ith pass is 0, so pass j, so 0 pass 1, so pass j zeros from ranges from 0 to 5. So first I'm going to compare 89 with 45. So these two elements get considered. And it is in out of order. So 45 is less than 89. So 49 moves front and 89 moves back. Next we are going to compare these two elements, 89 and 68. So again the 68 comes front and 89 gets swapped. Again we are going to consider these two elements, and these two elements are not out of order, so we are leaving out. So next again, so the process continues like this in ith 0th pass. So next the pass 1, so I becomes 1, pass j. So now we are going to consider 45 and 68. So no out of order. Here also no out of order. Here it is not out of order, and here also it is not out of order. If there is any out of order, the elements get shifted. Please note down here. So 89, 17, here it is out of order, so the elements get shifted. So in the ith pass, in the end of first ith pass, the last two elements get sorted, that is last two elements get fixed in its position. So now I gets incremented to 2, so pass of j will be ranging from 0 to 3, and again the same process continues, and at the end of the pass 2, last three elements 68, 89, 90 will find its place and gets fixed with its position. So next third pass, so I becomes 3, so j becomes 0, 1 and 2. So j will be having only 3 passes. Again the same procedure, we are going to compare 45 and 29. There is out of order, so there is a exchange of place. So again we are going to consider 45 and 34. Again it is an out of order, though we have to swap. Now again you have to compare 45 and 17, it is out of order, so we have to swap both two elements. So at the end of ith pass, third pass, the last 4 elements will find its position. So the passes continues at end of 5, that when I becomes 5, there is only one pass, and we are going to compare the first two elements alone. So 17 and 29 is in out of order, 29 and 17 is in out of order, so it gets sorted. And the final list becomes sorted. So this is the algorithm of the sorted bubble sort. Okay, so here the input is array of elements and output input is also the array of elements which is either sorted in ascending or descending order. Here the for loops ranges from 0 to n minus 2 and j ranges from 0 to n minus 2 minus I. So if j plus 1 is less than a of j, we are going to swap a of j and a of j plus 1. The analysis is, here the input size is n, which is number of elements. The basic operation is key comparison. Count of basic operation is given by summation formulas, and the time complexity is big of n square. The number of swap is big of n square. So it works under the best, worst and average case efficiencies.